months old. And tired.
I guess it's time to actually write this thing. Hello?
Oh no, it's happened again. Okay.
Where is... Oh, hey, I don't know how much time I have. I think Celine needs to put me in here. I just need a little bit of time. I'm gonna figure this out, okay? I'm not the bad guy here, okay? He does this sometimes. I'm gonna find a way to get out of here. Just humor him. I'm gonna figure this out. I'm gonna find a way to... Hey, has anyone seen someone that looks like me around here? Talks like me? Stick up his ass? Way too serious about things? Yeah, well, if you do, let me know, because that's a good problem that we need to fix later. Sorry, I just got here. Okay, what are we doing again? Let me check, is the microphone on? Hello? Sorry, I don't know how to use this stuff. Check, hello? Hello, test. Hello, test, 1, 2, test. Oh geez. You see, someone who is serious might prepare this kind of stuff so that it works as soon as I walk out, but not me. That's not something that I do. Okay, let's see. Oh yeah, I remember writing this. Okay, yeah, so TTTE A Cappella. Whenever I write a composition, what I try and do is target things that I haven't done in the past so that I can improve my total breadth of my skill set before I graduate. And I had 2 skill sets that I wanted to target. The first one was that I had never written SATB voicing before, so a cappella. I'd also never recorded vocal percussion or vocal a cappella before. And so I thought I'll tackle all 3 of these things and I'll do an a cappella piece. Now, the title of this piece is intentionally abbreviated, and the reason why is because part of this composition is that it's sort of a surprise as to what it is. I challenge you to see if you can figure out what it is before the first verse. Enjoy.
Do.
I finally get back here, and what do I find? You're playing Thomas the Tank Engine? That is so unprofessional. What are you doing? It's better than French music from 100 years ago, right? That French music has culture. Something you wouldn't understand. Okay, you know what? I'm taking back control. What am I wearing? That thing hasn't been washed in 6 years. I don't know what he was thinking. Oh, those are kind of comfy. Okay, sorry about that. Let's get back to the good stuff. So, as many of you know, I'm not actually a computer science, wait. Many of you know I'm not a music major, I'm a computer science major. So, I have skills that I can bring together to create stuff that requires both skill sets. And this next section is going to be basically about that. Before I get into those performances though, I would like to briefly talk about a little bit of mathematics and contextualize what computer science is. So computers are really, really, really fast. And part of the reason that they are fast is because they have these things called sorting algorithms that can put data in a specific way that allows it to run quickly. As a human example, if you go to a library, you're going to look for a book, right? And they probably have some sort of sorting system, like a Dewey Decimal System, right? But imagine if the library had just a pile, and you had to look at a book. That's not the right one. Another book, not the right one. It would take forever, right? Now, depending on the size of the library, if the library is huge, that could take so long that you would ever find the book you're looking for. Computers are the same way. They have to put information into a specific way in order to run at the speeds that they do. And so what is sorting? Well, let's pretend we have a set of items. We're going to call it X. There'll be a bunch of things in there, X1, X2, X3, all the way to the last item, Xn. In order for that set X to be sortable, every item within X has to follow two mathematical rules. The first one is that every item within X has to be a distinct item. In other words, all of the air in this room can't be sorted. That doesn't make sense, right? But if you were to blow up 10 balloons, using the air in the room, You could sort those balloons by size, the color of the balloon, the temperature of the air, whatever you like. They're now distinct once you collect them into specific sets. The second rule is that if you take the Cartesian product of that set x, so x squared, you're going to get a bunch of matched pairings, xa and xb. For every single one of those matched pairings, it needs to satisfy one of the following mathematical principles. X of A has to be greater than B, equal to B, or less than B. And when you do that, you get this fun little equation called the natural ordering, which is defined as for all of the items in the set X, X of n is less than or equal to X of n plus 1, which is the mathematical definition of sorted. Now there's something interesting with that second part though. There is a pragmatic approach to natural sorting solutions without Cartesian practices, which gets you higher throughput, higher efficiency, and normalized runtimes. When you do the amortized analysis of that sorting X, you can prove that you can actually get runtimes of n for both big theta and small theta. Okay, you know what, I'm just going to skip through this. Okay. So how does this relate to music? Well, we're finally here. I took the set of the C major scale. It looks like that. It sounds like this. Great. I then defined the natural ordering of that scale to be based on pitch. The lower the pitch, the earlier it is in the set. So it sounds like this now. Now, you can shuffle that scale into any arbitrary ordering you want, it doesn't matter. But what I did is I then told the computer, hey, I want you to sort that. Put that back to the natural ordering. And if you remember what I said earlier about how the second property of ordering is that it needs to be able to compare some A against some B. Well, a sorting algorithm literally just does that over and over again until it's back into its natural ordering. So every single time the computer compares, say, a note XA against a note XB, it's going to play that corresponding tone. And as the sort finishes, you're going to hear an audible representation of what that sorting algorithm sounds like, which creates kind of a cool sound. It's not necessarily music, but it's a cool sound. So what I did is I then took that sound and I compared it and combined it with several different scales, sorting algorithms, chord progressions, percussion sections, and a hidden meter to determine the speed and feel of that sort, and you get music. Now, from there, I told the computer, I'm going to give you 6 words, 6 distinct words, and I want you, the computer, to generate 6 movements out of those 6 words. Now, because it's a computer, and it's just an artificial intelligence, it doesn't really know anything, but what is cool about it is the title. This number, 7.48 times 10 to the power 75, isn't just a random number. That is actually the number that represents the total number of what are called permutations that this program can generate. So, that's how many unique compositions that this program has inside it, essentially. Now that number probably means like nothing to you, and I don't blame you if it does, so I'll contextualize that. That number means if you took all of the matter in the observable universe, and you created human beings out of that matter, and then you forced those humans to watch this composition since the beginning of time, you would need to repeat that process 200 billion times for a less than 2% chance for this program to ever output the same thing twice. Mathematicians call that 0. It won't happen. In the context of the human experience, this is an effectively infinite number of compositions. Now, you've probably heard a lot of music in your life, and a lot of that music is pretty bad, and only some of it's good. It's the same thing with this program. What it plays might not sound very good. It might sound kind of weird and uninspired, but it also could sound really, really cool. And that's kind of the beauty of it. What you're about to hear has never been heard before. And once it's done, it'll never be heard again. Well, I mean, we are recording. I'll just cut it out of the recording and I'll delete it and I'll abandon it so that it'll never exist again. So you get the true experience. So, will it be good or not? Let's find out. Okay, I think that was actually pretty good. Now, it's a computer, right? So it doesn't actually choose what it's doing really like a human would. And you can see bubble sort ran 3 times in a row. There's way more than bubble sort in there, but you don't really get to hear the full breadth of what this composition is capable of. So if you would like to, after the recital, I will be setting up a small little demo station here that you can come around and play with the sandbox version of this composition, where you can actually choose the progression and the speed and all the little settings you can choose to create your own sound. If you would like to, if you're interested, feel free to come on out. I have my computer right here. We'll play it through the speakers, and you can find out what more this composition is capable of. I'm going to move on here, though, to pitch games. I'm going to leave this QR code up here for a little bit if you would like it. If you are a brass musician or you are a music educator with brass students, you may want to scan this QR code and bookmark it. There is also a copy of that on the program as well. So if you want to take it from there, that's fine too. What this program is, it's actually just an exercise to help brass musicians. Now, if you don't know anything about how brass instruments work, I'll explain it really quick. If you've seen a trumpet, it has 3 buttons on top, right? Now, trumpets can play way more than 3 notes, right? The 3 buttons aren't the whole thing. They have partials, and the partials allow you to choose your starting note, which follows the universe's physical constants represented by the harmonic series, which sounds like this. Something like that. It's not exactly perfect, it's a piano. But essentially, brass musicians, they can choose that starting pitch, right? And then using those 3 buttons, they can decrease the pitch for the desired note. The advantage of this is that it decreases the complexity of the instrument, right? You only have 3 valves to ever do work on. You only have to oil it. And it's way cheaper, as opposed to, say, a saxophone, which has all these buttons on it, levers and pads, and there's way more maintenance involved. The downside is that you have to learn how to play partials, which kind of sucks. But this exercise teaches you, in my opinion, the best way to learn partials. So when you load this application up, it's going to look like this. You're going to have a bunch of settings and things you can choose from. The length of the exercise, I recommend to pick a length based on the amount of notes that you can play in one breath. And the reason for that is because as your tank runs out, your ability to navigate these partials changes as well. So as long as you can hold a full exercise for one breath, that's fine. Then you can pick your range. You can go all the way from G below the staff, all the way to C above the staff. Anything outside of that, and you're working with pedal tones and range exercises, and that's something different. So don't use that for this, that would be silly. And then you can pick your clef. I put all the clefs that I know of in there. If there are more that are common, I mean, feel free to let me know, but I'm pretty sure that's all there is. And then if you're working on sight reading as well at the same time, you can also increase the amount of accidentals that appear. So you can set that to 100 and it'll be all flats and sharps. That way you'll also be working on your ability to read flats and sharps. Then you just start the exercise. And then you just keep generating them as you need them. And then once you're done, you just generate a new one. The way that this worked previously was all by hand on paper, and that takes a very long time. This is way more efficient. So again, if you're a brass musician, feel free to use this. If you have students that are brass musicians, feel free to show them this exercise. It was created by Dr. Marty Robinson, and I just digitalized it so that it wouldn't take so long to use, essentially. There is actually one more feature that I want to show you with pitch games. It was suggested by a friend. I only just programmed it like a few days ago, though. So I haven't bug tested it. We'll see if it works. Let me pull it up here. Okay. Oh. Hold on, let me try it again. That might just be a fluke. Oh. Oh no.
It is I, the Tech Grinch. Have you ever wondered why your technology seems to have a mind of its own?
No, we haven't.
Well, it does. It's my mind. A mind of trickery and
Don't bring it
deviance.
to song. Don't do
I
it.
hide behind every screen, waiting for the perfect click of the mouse to give you the most perplexing, unhelpful error message I can. I'm the Tech Grinch. Installing malware. The Tech Grinch. Deleting family photos. The Tech Grinch. The source of every glitch. the one that drops your calls. I'm corrupting your files. I will sink as low as an automatic update. I'm the Tech Grinch, crashing your software. The Tech Grinch, how about a new user interface? The Tech Grinch, and I'm the source of every glitch. It seems your printer is out of cyan again. I'm the one that drains your battery. That's not all. How about a quick lightning round? Seg fault, kernel panic, memory violation, out of bounds, timeout, null pointer, mission, unhandled promise, illegal race, conditioning, kernel panic, out of bounds, memory violation, null pointer, database offline.
Oops, you have to put the CD in your computer.
Is that all? Probably not. That's just the beauty of it. You'll never know when I'll show up again. So remember, I'll see you again soon.
That video basically explains what it's like to be a computer scientist every single day of your life. But I also know that it's very relatable for all of you to be trying to do literally anything and then it doesn't work. So hopefully he doesn't show up again soon.
Finally, is it my turn again?
No, we have to take this seriously. I told you earlier.
But I don't want to play silly music. Silly music is way better.
Wait, what if we played music that was silly and serious?
That's so meta.
You wrote that joke. Are we gonna do this or not?
Alright, this could be good.
everybody. Really appreciate it. The composition I wrote earlier about the sorting algorithm, feel free to comment down. We'll set it up right now for you if you're interested. Thank you so much. Have a good afternoon, everyone.